Hello guys, welcome to this new session. We will continue developing our end language, and in this session we will treat inheritance. So let's see this example. We have two classes. The first one is the superclass that has one function that print from superclass, and the second one we have subclass that inherit from superclass, and it has the same function that declared in the superclass, but it's overridden and it says from subclass. The token that we will use to do the inheritance is the token less. So in the semantic of the end language, the inheritance is done by a token less. So let's see. First of all, we will have a superclass object that has, as usual, it has a function, closure f super, and name it f super with the key f. So this object, we know how to create that, and we did that in previous sessions. So let's see. So when we create a subclass object that has the name subclass, and it has the same function as the function in the superclass. So what we need, first of all, we need to push or to move or copy every function in the methods of superclass into its subclass. And then after we have some definition in the subclass, we will override this one with we override the implementation or the function in the subclass instead of the superclass. So as you see, previously we have a closure, the function that has the implementation of super function, and then when we have some bytecodes that do method declaration, we then put at the same place the new function with the same key f. So that will help us when we need to call a function. We will first of all call this one. So we suppose that if we suppose that we don't have this f function, normally we need to call the super function. So let's see the bytecode. As you see here, I put the bytecode only for inheritance. So first of all, we get global superclass. I get this one, and then I will get the class subclass, and then we have a new bytecode called op inherit. So the VM where it reads that bytecode op inherit, it will push every methods that exists in the superclass into the methods that exist in the subclass, into the hash table in the subclass. So op inherit will copy every method in the superclass in the hash table of methods in the subclass. Then we need to push another time the subclass, because we need to prepare that we have other methods that need to be pushed to the subclass, because at the operation op inherit, after that we need to pop that subclass from the stack. So we need to push another time the subclass, because we need to add methods that declared in the subclass. So this is treated in the section of methods, so go and watch it. So in the perspective of the stack, we have the stack state, we have the superclass here first and the subclass, and after inheritance the only thing that exists on the stack is the superclass. So why is this? Why we don't push the subclass and then the superclass? You will understand that later when we treat the keyword super. It will be useful that we have the class, the superclass at the top of the stack. So let's jump to the code and implement that. So let's go first of all to vmtable.c, and we will add at the end, we will add here a function that copy all the things from the table from into table 2. That's the function that we will use it when we do some inheritance. We need to copy every method on the superclass into the subclass. So here I will loop over every entry in the from table, and what I will do is to get the entry from the from hash table, and I will check if entry key is different than null. Then I will copy that into the to table set to, and entry key with the same value. So that's it. So let's go to hash table to the header, and let's add the signature in here. So void table add all table from and table 2. So that's it. So let's go to our chunk to add the new bytecode. So I'll add it here, up inherit. So we add that up inherit, that to inheritance. So let's go to debug to debug that, and we will add it after that. Case up inherit, and I will return simple instruction up inherit offset. And that's fine. So let's go to our compiler to see how we will compile that. So let's go to our grammar, and we will add in the class declaration how the inheritance done. So we will have a token lower, less, and another identifier. It's optional. You can inherit, and you can inherit from a class, or you can just declare a normal class. So let's go to class declaration, and first of all I need to memorize the class name. So parser previous. And what we need to do is go here, and I will check if we have a tokenless. So if yes, then we will do inheritance. So first of all I will consume token identifier. So, and then I will raise an error if not, says except superclass name. Then what I need to do is to call variable, because I need the superclass as a variable, so I needed to emit that bytecode up get global that, so I need to call that function to handle that for me. And then I will check using the function identity. So I need to check if the class name is equal to parser previous. So if so, so the user it So in that case, if true, so some user could do something like that: class A inherit from class A. So we cannot inherit from the same class, so I will avoid that. So what I need to do is to call error, and a class can't inherit from itself. So that's it. And then what I need to do is to name the variable on the class name. So I need that to handle for me the object subclass, and the subclass I have stored in the class name. So that's, I will pass false for can assign, and I will emit byte of inherit. So that's it for inheritance, and then we'll continue creating methods and so on. So let's compile that and see if we have any error. Identify, okay, then compile it, let's see, identifier. So everything is good. So let's go to the VM and add that bytecode. So in here I will add op inherit. So after this, case op inherit. So first I will store the superclass as a value, and I will pick it from the stack at the position 1. So we have the top of stack here, so the superclass, it exists at the position 1 from the top of stack. This is the position 0 and this is the position 1. So then I will check is class, so it must be a class object, so I need to check that. If it is not, I will raise a runtime error that says superclass must be a class, and I will return interpret runtime error. So then I will create the class object subclass, and I will pick it from the position 0 from the top of the stack, and then I will call the table add all from as class of the super class, and all the methods must be copied to the sub class methods, and then I will pop the subclass from the stack, and then I will break. So that's it. So let's clean and make all of that. So everything is good. So let's create a simple sample. So let's delete all that. So let's create a superclass with a function that print from super class, and let's create a subclass with a function print from subclass. So let's create an object from the subclass, and let's call the f function. So this must be printing from subclass because we have an override of the same function. So let's get a sample and let's run this on it. So it print from subclass. So let's see the bytecode. For the definition function is normal. So let's see. This is the declaration or the definition of the superclass, and then so I need to change something. So for the debugging of vim debug.c, for the debugging of get global or get local, I must use not byte but constant instruction, and also for get global. Why is that? Because I want to see also the name of the variable. Equaling, so that's good. So let's rerun our interpreter on the script. So as you see here, we have the get global. So, and then we have the definition of method in the superclass, and we have the declaration of subclass and define it, and then we get global subclass. Why? Here so let's go, because I want another subclass on the stack. So what I need to do is go to the compiler.c and go here. Now here is class name. So that's it. So let's see the bytecode. So here we have subclass, and we define that subclass. Oh, I did an error. So I didn't mention the inheritance. So this subclass, it should inherit from the superclass. So that's it. So let's create that, and so let's see it's simple. So as you see here, we have the first bytecode is for superclass, and for inheritance is this. So I have the subclass, define the subclass, and I will get the superclass as this. I will get the superclass, then I will get the subclass, and then I will have an inheritance. So after inheritance, I need to push to the stack another subclass, because I want to define some new methods. The method that declared in the subclass, and other ones is for just for instantiation and invocation of the function. So let's see when this is at 11. So let's start from 11. This is defining that. So I will get the superclass. Here you see we have a superclass, and then we get the subclass, and you see we have the subclass at the top of stack. So after inheritance, we have only left the superclass at the top of the stack. So as you see, it's like this. So then I will get another subclass and push it to the stack, because I will declare a new method, a new closure. So as you see, we have here a declaration method and so on. So let's see when we have a call. So we have a call of invocation. So at the top of stack we have an instance, then we have a subclass instance, and then the function of the subclass f, it will be called. So we have load into the stack from subclass the string from child, then we print that and we continue doing the rest. So why I let this superclass here at the top? Because guys, as I mentioned before, I will treat that in another session, because we need that the superclass exists on the stack, because then we will treat the keyword or the variable super. So that's good. So let's see if we uncomment the macros that shows the debug. So let's see, look at sample. So as you see, from subclass. So let's come back and just give that another name. So for instance, let's name it T. So T doesn't exist on the, so no, it's not like that. So let's remove remove the override from here and see what will happen. So let's cut the sample and let's run it. So it says from superclass. So what happens here? So the function doesn't exist on the subclass. So we need to go up to the superclass and search if we have an have the same function, and then we run it. So let's also add, for instance, let's add another function called T, for example. I will print T, and then I will go and call that T function. So let's get that, and as you see, as you will see right now, it calls the function from the superclass, and then I will call the function that exists only in the subclass. So that's it. So let's okay, from subclass, and here you will see an error because it will run the subclass, it will run the function f, and it will run the implementation that exists on the superclass, but then it will raise a runtime error that says undefined property T, and that's correct. We don't have this property either in the subclass or the superclass. So guys, we've reached the end of the video. So we are so good at this stage because our language is now capable to do inheritance, and also it has also polymorphism because it calls the function that override it. So that's it guys, see you in another session, and then we will continue developing the concepts of OOP. So see you guys.